Hello and welcome to my channel. So today's topic that we are going to learn is Euclid's division algorithm. Okay. In last class we did Euclid's division lemma, right? So this is Euclid's division algorithm. Okay. So as I've told you earlier that Euclid's division algorithm is a technique to find HCF of two numbers, two positive integers. Okay, what is HCF? Highest common factor. Yes, I have explained this concept in introduction class, but still for you all I'll recall it again. Okay, so HCF of two numbers is what? Suppose you are given two positive integers 15 and 30, say. Factorize these two. This is 3 into 5 and this is 2 into 3 into 5, right? So which is the highest common? That means which is the common number and also the highest one. Which is the common? Common is this, right? And it's also the highest, right? So that means HCF is 3 into 5, which is 15, right? Okay, so this is your concept of HCF. But if you are given bigger numbers like 444 and 9191, yes, if you apply this method here to find HCF, it will take a lot of time, right? Yes, it will be time consuming. But this Euclid's division algorithm, by this technique we can find HCF of bigger numbers in a short time. Okay, we can find HCF of any numbers, okay, by using this algorithm. But it's an advantage that for bigger numbers it will not take much time. Okay, you can do it very quickly. Okay, so this was your concept of HCF. And one more thing, HCF is also called as GCD. Okay, HCF is also called as GCD. Okay, HCF is your highest common factor and GCD is your greatest common divisor. Okay, it's one and the same. Okay, yeah, let us come back to this division algorithm, Euclid's division algorithm. Okay, what do you mean by algorithm? So algorithm is a stepwise process to solve a problem. So algorithm basically consists of certain steps which help us to solve a problem. Okay, so that is the meaning of algorithm. Okay, so let us see what are the steps in the algorithm. Okay, so let me write all those steps. So as you can see, I have written the steps to find the HCF of two positive integers. Okay, so these are the steps. We will follow these steps and we will find HCF of two positive integers. So let us take the first example. Okay, 455 and 42. Okay, so we are going to find HCF of these two numbers, 455 and 42. So what is the step 1? So step 1 is identify the greater number of the two. So which is the greater number? I'll tell you some other. Okay. So which is the greater among these? 455, right? Yes. And what is the second step? Consider the greater number as dividend and the smaller one as divisor. Okay, so that means dividend is 455 and divisor is 42, right? What is dividend? Is the number which you will divide, and divisor which divides, right? So 42 is going to divide 455. Okay. What is the third step? Find the quotient and the remainder. This third step, find the quotient and the remainder. How to find quotient and the remainder? Use your division, right? Normal division, which is your Euclid's division lemma. Okay, so Euclid's division lemma is nothing but a normal division. It's a basic division which you have learned in your earlier classes. Okay, so let us do that. Okay, and before moving into division, let me tell you, I'll be showing you two representations of division. Okay, so let me do the partition here. Beta, for that you should before doing the division, you should know this division dividend is equal to divisor into quotient plus remainder. Okay, your textbook is using this representation. Okay, I'll be showing you both the ways, the normal division, the basic division which you have learnt, and this division also. Okay, so let me put it in a box. Okay, so what is the step? Yes, we have to find the quotient and the remainder. So let us find quotient and the remainder. So 455 is your dividend and 42 is your divisor, right? So I'll write in this form, 455 equal to 42. Okay, so 42 tens are 420, right? Correct. So what is the remainder then? 35, right? So what I'm going to do, I'm going to write this same thing here but in different form. So 42 into divisor into quotient, right? So quotient is 10 and remainder is 35, right? Correct. I'm just using this formula here. Okay, both of these are same things. Okay, both of these are same, only forms are different. Okay. Okay, now we have found out the quotient and the remainder, right? According to the Euclid's division algorithm, quotient is what? 10 and remainder is 35, right? What is the next step? If the remainder is 0, then the divisor is the required HCF. Otherwise, go to the next step. So our remainder is what? 35, right? It is not 0. Remainder is not 0, right? Remainder is not 0. So we have to go to the next step. What is the next step? Take the remainder as the new divisor and divisor as the new dividend. Okay, I think I've written this. This is dividend. Okay. Yeah, take the remainder as the new divisor and the divisor as the new dividend. So you take the remainder. So your remainder is 35, right? So it will become the divisor now. You're getting? See, 35 is going to become a divisor. It is in place of divisor. And your divisor is going to become new dividend. So what is your divisor? Divisor is 42, right? So 42 will become dividend. Okay, let me just See, what is the step? What is the step? If the remainder is 0, then take the remainder as the new divisor and divisor as the new dividend. That means remainder will become new divisor. So remainder is going to become new divisor. So this is the place of divisor, right? And 42, which is the divisor, will become new dividend. So this is the place of dividend, right? Then I'll show you here also how it is. So 35 is your divisor now. So this is your divisor and this is your new dividend. This is your new divisor and this is your new dividend, right? So yeah, this is a step we got. And then what to do? Repeat steps 3, 4 and 5 till the remainder 0 is obtained. Okay, so which are the steps 3, 4, 5? That means you have to find the quotient in the remainder. Then you have to check if the remainder is 0 or not. Okay, if it is not 0, you go to the next step. And then again, you take the remainder as the new divisor and divisor as the new dividend. Okay, so let us apply division to the new divisor and new dividend. So which are our new divisor? New divisor is 35 and new dividend is 42, right? So let us apply division to these two numbers. So 42 so 35 ones are 35, right? So what is the remainder? Remainder is 7, right? So I'll write here also side by side in this form. 35 into 1 plus 7. See, don't get confused like how I'm writing this. I'm just using this, okay, formula. So don't get confused. Okay, so remainder is not 0, right? So what we have to do? Yes, take the remainder as the new divisor and divisor as the new dividend, right? So let us do that. So 35 5s are 7 5s are 35, right? So remainder is 0, right? And what happens when the remainder is 0? Okay, let me write here also. So this will be, so I told you, when the remainder is not 0, what happens? Your remainder becomes new divisor. So it will come here. And your divisor becomes new dividend. It will come here. 35, right? 35 into 5 plus 0. Okay, so now see, we are getting remainder 0, right? So see the steps. If the remainder is 0, then the divisor is the required HCF. If the remainder is 0, then the divisor is the required HCF. If you see remainder is 0, that means HCF is the divisor. 7 is the divisor, right? Correct? 7 was dividing 35. So 7 is nothing but our HCF. Okay, so HCF is HCF of 455 and 42 is 7. Okay, so 7 is the HCF of 455 and 42. If you want to verify that 7 is the HCF of 455 and 42, you can do by factorization and check. Okay, so let us check if 7 is the HCF or not. Let us verify it. So 455 and 42, right? Let us factorize this. 5 9s are 45, 5 1s are 5, then 7 13s are 91, and 13 1s are 13, right? This is what you get. 5 91s are, yeah. Then 2 21s are 42, 3 7s are 21, and 7 1s are 7, right? So if you see, 455 is 5 into 7 into 13, and 42 is 2 into 3 into 7. So can you spot which is the HCF? Yes, it's a 7, right? So that means it is correct. So 7 is the HCF of 455 and 42. Okay, this is for verification we did. We'll look at one more example. You will understand it more better. Okay, so let us do the second example. Where that thing went. $420 and 130. Okay, so which is the greater one among these? 420 is a greater, right? So this is your dividend, right? And this is your divisor. Okay, so find the quotient and the remainder. Okay, so let us do that. I'll show you both the ways. Okay, so this is 420 and this is 130, and 420 and this is 130. So by now you should be able to write in this form, okay, without looking at this, formula. Okay, you should be able to write directly in this form. So let us do 420. So 130, what should I put? 133 is a 390, right? Yes. Yeah. What is the remainder? Remainder is 30, correct? So I'll write here also 3 plus what? 30, right? Yeah. So remainder is not 0. So this becomes your new divisor, and this is your new dividend. So 30 into 4 is 120, right? So this is how much? 10, right? So I told you 30 will become new divisor and 130 will become your new dividend. So this will be 4 and this is 10, right? Then yeah, so this is your new divisor. This is what? 30, right? So 10 into 3, which is 30. This is 0 0, right? So write here also. So 30 is your new dividend and 10 is your new divisor. So what should I put? 10 into 3 is 0. So I have got remainder as the 0. That means my HCF is what? My HCF is the divisor 10. Okay. See the statement, last step. The last divisor for which the remainder is 0 is the required HCF. The last divisor for which the remainder is 0 is the required HCF. So for this divisor, I got the remainder 0, right? For this divisor, that is 10, I got remainder 0. That means my HCF is 10. So HCF is HCF of 420 and 130 is 10. Okay, so I'll give you one problem for you to solve. Okay, so take this example, take this as an exercise, and you can give me the answer in the comment box. Okay, so the two numbers are 267 and 39. Okay, so this is for exercise. Okay, give me the answer in the comment box. Okay, so this is nothing but your Euclid's division algorithm. Okay, so I hope you must have understood this concept. We will be doing exercise based on Euclid's division algorithm in the next class. Okay, so yeah.